Today we're going to talk about solving two-step equations. If you remember from last week, we discussed how to solve equations where a number is either added to or multiplied by a variable. Well, today we're going to combine these two steps and solve equations where a number is both added to and multiplied by a variable. So let's look at it. Okay, first let's remember, what is our goal when we are solving equations? If you recall, our goal is to get x equal to some number. Now, looking at this, what number or numbers do we want to see disappear so that x is by itself and isolated? If we're looking at it, we want 2 to go away and 4 to go away. Okay? So we want to say 2 and 4 need to go away. Now, which number would we want to see disappear first? And this is kind of a tricky question, but it has to do with PEMDAS. If we think of, please excuse my dear Aunt Sally. When we're working to solve equations and plug numbers in to equations, when we want to plug numbers into equations and evaluate, we will work our way down PEMDAS. When we are looking to solve equations, we're going to work our way back up PEMDAS. Now, you don't have to, as we'll see in a few minutes, but it's easier if you do it that way. So, the first number we want to see disappear is the ones that are added or subtracted to our variable, and that would be 4. Now, how do we make sure that 4 disappears? Well, since 4 is added to our term with the variable, we're going to use our additive inverse property and add its opposite, or subtract 4 from each side. So we're going to use the additive inverse property and our property of equality to make these operations happen. When we're done, we're left with 2x plus 0 equals 2. And then by the identity property, we know that 2x equals 2. Now we're left with a second problem where we have 2 that's multiplied by x. And now we know how to solve this type of problem because we did it last time in class. We can either multiply by 1/2 or divide by 2 on both sides. And that's our multiplicative inverse property as well as our property of equality that tell us to do that. And we are left with x equals 1. Now, by our identity property, make sure to check your work with this. So to check our work, we're going to plug in 1, substitute 1 in for every time we see x in that original equation. So 2 times x will be 2 times 1 because we're saying x equals 1. Plus 4 equals 6. Okay? Now on this left-hand side of the equation, we're evaluating it. So we're going to work our way down PEMDAS. 2 times 1 is 2, plus 4 indeed does equal 6 and create a true statement. So we know that this solution is correct. Now let's look at another way to solve this problem. What if, instead of subtracting 4 from each side, we divide by 3 first? Instead of working our way down PEMDAS, or working our way back up to PEMDAS, we'll do it like we're working our way down. Well, in this case, we're going to have to divide both sides by 3. Okay? That would be our multiplicative inverse property and our property of equality. And that will give us 3x over 3 plus 4 over 3 equals 6 divided by 3, which is 2. Actually, let's go ahead, and it's easier if we do it this way, to just leave it as 6 over 3. Well, 3 divided by 3 is just going to be x plus 4/3 equals 6/3. Okay? So in this case, we would want to subtract 4/3 from each side. Well, 6/3 minus 4/3 is just x equals 2/3. So even though we divided first and then subtracted, we were still able to come up with an answer. So does it really matter which operations you do first? No. Some are just easier than others. So let's try this again. First, we're going to make the variable added to the number disappear, which is going to be our 2. And since it's added, we're going to add its additive inverse, which is -2, to both sides, again by our additive inverse property and our property of equality. And we'll end up with 4x equals 8. Using our multiplicative inverse property to multiply both sides by 1/4 or divide by 4, we will get that x equals 2 by our identity property. Let's check our work though. We have 4 times the value of x, which is 2, plus 2 should equal 10. Well, does 8 plus 2 equal 10? Yes, it does. So we know that this solution is good. Now, which way was easier? For me, I like to take care of my addition, and then the last thing that I always do before I solve is to do my division. Okay, now I want you to try a couple of these on your own. Let's say that you have problem 1. That's going to be 2x plus 4 equals 8. And problem number 2, I want you to do 3x minus 5 equals 8. Okay? Now I want you to stop this recording, solve these problems, and then join the recording back. Okay, to solve problem number 1, we're going to first subtract 4 from both sides using our additive inverse property and our property of equality. And that will leave us with 2x equals 4. Now we're going to divide by 2 or multiply both sides by 1/2 using our multiplicative inverse property and our property of equality. This will leave us with x equals 2. To check our work, we're going to substitute this value of x equals 2 into our original equation. So instead of x, I'm going to write the value of x, which is 2, plus 4 should equal 8. And does 4 plus 4 equal 8? Is that a true statement? Yes, it is, so we know our solution is good. Okay, problem number 2. First, we're going to add 5 to both sides because 5 is the additive inverse of -5. And that uses our additive inverse property and our property of equality. And we're going to get 3x equals 13. Now, using our multiplicative inverse property, we will divide by 3 or multiply by 1/3, same thing, and our property of equality to do it to both sides. And we're going to get that x equals 13/3. And that looks a little odd there, so let's rewrite that 13. Now let's check our work. Notice that this is an improper fraction, so I just left it as an improper fraction. Does 3 times 13/3 minus 5 equal 8? Well, your 3's cancel, so you're left with 13 minus 5 equals 8, and that is a true statement, so we know this solution is good. Thank you for joining me for this video, and we'll see you in class.